Hi everyone, in today's lesson we're going to talk about rational functions and how to find slant asymptotes of rational functions. First, by definition, a slant or oblique asymptote occurs when there is no horizontal asymptote, or when the degree of the numerator is greater than the degree of the denominator. So what exactly am I talking about? Right here, if you look below, there's a graph. This graph is a rational function that has something that we call a slant asymptote. So see right here, this line that's going down here, or if you went up, it's going like this. It's slanted. It's not exactly horizontal and it's not exactly vertical. This graph here definitely has a vertical asymptote right here at x equals 3. Again, no horizontal asymptotes anywhere, but this slant asymptote is the equation of the line y equals 2. Just a refresher, when I have a line, it's y equals mx plus b, where m is your slope and b is the y value of the y-intercept. So if we look at this graph right here, this line intersects the y-axis at 0, 2. So the b value, 2, is the y value of that intercept point. Okay? And the slope of m, or 1 over here, slope of 1, goes up 1 over 1, up 1 over 1, up 1 over 1. That's how we make that line. And this is the rational function here that graphs this piece here and this piece here. So let's talk about how to find these things from the equation. Let's just prove what we just found here. So we know that to find a vertical asymptote, we're going to take the equation, which we have here, and set the denominator equal to 0. So x minus 3 equals 0, and we'll solve. We add 3 on both sides. So the vertical asymptote is, in fact, x equals 3, which we got here. So if you want to write down the steps again, a vertical asymptote is the undefined values. And the way we find those is by setting the denominator equal to 0. Now, if we wanted to find a horizontal asymptote, what we actually would have to do is look at the degree of the numerator and the degree of the denominator. The degree of the denominator is 1. So it says here that the degree of the numerator is greater than the degree of the denominator. So the degree of the numerator is greater than the degree of the denominator. Therefore, there is no horizontal asymptote. HA for horizontal asymptote. So that means there must be some other type. There must be a slant asymptote. So the way that we find the slant asymptote is actually through long division. So let's write down we're going to use long division. So we're actually going to take, in this rational function right here, we're going to take this value and divide it by this value. So we'll put the x minus 3 on the outside. And on the inside we'll put x squared minus x minus 2. No placeholders necessary. And now let's just divide. How do I go from x to x squared? I need to multiply by x. And then we'll multiply. X times x is x squared. X times negative 3 is negative 3x. And we subtract. Those cancel. And here we have a negative 1 minus a negative 3. That's 2x. And bring down the minus 2. And now how do we multiply, or how do we go from x to 2x? And we're going to multiply by 2, and then multiply 2 times x, we get 2x minus 6, and we subtract. And when we do negative 2 minus negative 6, we get 4. So most of the time there's going to be a remainder, but the remainder is not what we're going to look at. So this x plus 2, your quotient without the remainder is your slant asymptote. So the answer is y equals x plus 2. Be careful, you always have to write it as y equals, because we're writing the equation of an asymptote, which again is what we got. If you want to look up here, This is my equation right up there of my slant asymptote. All right, so another piece that we're going to have to do is long division. We could have technically, if we wanted to, use synthetic for this because of the form of the divisor. So let's just test it out. We'd put the 3 here, a 1, a -1, a -2. Bring down the 1, multiply, add, multiply, add. So this would be 1x and then plus 2. That would be my equation, right? So be careful. I mean, you can use long division or you could use synthetic, whichever is easier, unless the question asks specifically to use a specific way. All right, let's try another example now on the back. Okay, so here's another one, and I want you to find more pieces this time. I want you to find the domain, the x-intercepts, the y-intercept, vertical, horizontal, and then lastly, find me the slant asymptote. So, okay, before you begin, there is a typo. Just get rid of this -2 here. It just should be x squared minus x minus 12. Okay, so again, to find the domain is all real numbers except the undefined values. All right, now an x-intercept, we solve that by setting y equal to 0. An x-intercept, a y-intercept, we set it by finding x equal to 0. A vertical asymptote are the undefined values. And the horizontal asymptote, we look by comparing the new degrees of the numerators and denominators. Okay, so it's good to write down a few steps. All right, see if you can do the rest. See if you can find the domain, the x-intercept, y-intercept, vertical asymptote, and horizontal, and then hit resume for the answers. Okay, here are your answers. Alright, so the domain I got was all real numbers except for when x was equal to 5. So what I did was I set the denominator equal to 0 and solved. And then I said all real numbers except for when x equals 5. For an x-intercept, I set y equal to 0 or f of x. So I turned f of x into 0 and I cross-multiplied. 0 times x minus 5 was 0. This times 1 was just this. I factored, I t-charted, and I remembered to make x-intercepts out of points, not x values. Then I have a y-intercept by setting x equal to 0. I did that. I got -12 over -5, which was positive 12/5. And again, I made it a point. My vertical asymptotes are the undefined values. So when I saw x was undefined at 5, that's my vertical asymptote. And my answer for horizontal asymptote was that there is none. There is no horizontal asymptote because the degree of the numerator was greater than the degree of the denominator. Okay, now the last piece that I wanted to do was the slant asymptote. And remember, we needed to use long division. So I think this time I'm going to use synthetic. So the divisor is x minus 5 into x squared minus x minus 12. So I'm going to just use long division. I'm sorry, synthetic. So here's 5. I take the root, put the coefficients, 1, -1, and -12. Bring down the 1, multiply, add, multiply, add. So since the degree is x squared, when I do synthetic, it's 1 less. So this is 1x. And the 4 is the number. So the final answer is y equals x plus 4. That is my slant asymptote. Now, okay, jot down any questions you might have and please ask them in class tomorrow.